Okay, this question is about having inductors and capacitors in circuits and what happens when we get resonance. So first of all, has to find the resonant frequency, so we use this form to find the resonant frequency. There's the inductance, is the capacitance, it's given on the data sheet. So we find the resonant frequency using this formula, and then what's the current flowing at resonance? Well, there's a shortcut to find the current at resonance, because if you remember the idea, we have XL, which is the inductive reactance, and XC, which is capacitive reactance. When they're equal, i.e. at resonance, they cancel each other out, and so all we're left with is the pure resistance of the circuit. So at resonance, the easy way to find the current there is just to ignore the effect of the capacitor and inductor because they've been cancelled out, and just treat the circuit as having a resistance of 10 ohms. Once we've gone beyond resonance, i.e. at half the resonant frequency or double the resonant frequency, then we need to calculate what's the impedance at these frequencies and use the formula for finding the current. I would recommend using the complex number method, as we've done in previous questions. So have a go at this question. Here are the solutions. I agree with those solutions this time, and then I'll run through them below. So pause and have a go. Okay, first step, find the natural frequency or the resonant frequency. So plugging the values in, 50 millihenries and 0.05 microfarads gives us this as the natural frequency. For part B, using Ohm's law, the current just turns out to be 10 amps. And then we have to, for half the resonant frequency, find the impedance of the inductor, which turns out to be 500, and the impedance of the capacitor, which turns out to be this, using the formulae. So therefore the total impedance is 10. We've got 500 ohms acting in the inductive sense and 2000 in the capacitive sense, so subtracting we get minus 1500 J. We're going to use that method, which is pretty well all along the imaginary axis, so the phase angle is going to be practically minus 90 degrees, and the resistance is going to be around about 1500 ohms rounded, so in other words this is almost ignored. So now what's the current? Voltage over resistance, 100 over 1500, minus 90 gives us plus 90 degrees, so we've got a current of 0.07 amps leading 90. And repeating for double the resonant frequency. I won't run through it in detail, but if you want to have a look, here is the solution. For the impedances XL and XC, and then the rest is the same.